15 minutes per question, so it adds up to 45 minutes total. Okay, I am going to give you a practice FRQ. You do not have to do it. If you're about to drop this class and you don't give a crap, don't do it. Doesn't matter. It's not for a grade. But 4 questions, 3 of them are very similar to the 3 FRQs you're getting on Monday. So if you work through all 4, you'll be very well prepared for the 3 that you'll get on Monday. Okay, I'll pass that out tomorrow. I'll post the answer key online. Look over it. Make sure you understand it. Try it on your own. Okay, and then CBA corrections are today after school. Tomorrow during lunch is fine. And then I will stay till 5 tomorrow, even though I hate that, okay, to make sure you have time also on Monday. Okay, all that's in your Mind 101. Ready to go?
Yeah.
Okay. Look at your first page. We should just kind of burn through, not every question, but some examples from each question. So look at number 1. What do I do? Okay, I could factor, but do I have to? The first thing that you should try is just to plug it in. So if I do -1 squared, what's that? 1 plus 3 times -1 is -3. 2? 2 plus 2?
1 is plus 1.
So the top comes out to be 0. Okay, now on the bottom, what's -1 squared? 1 minus 1 gives you 0. That's when you know that that's not going to work. So your choices are factor cancel, which somebody said, or you can do L'Hopital's rule. I'm going to do L'Hopital's rule, but you can do what you want, because I know some of y'all still can't factor. Okay, so derivative on the top, what is it? 2x plus 3. What's the derivative on bottom? And now plug in -1. So L'Hopital's rule, when you get 0 on top, 0 on bottom, you just take the derivative of the limit separately, then stack them back up. So on top, 2 times -1 is -2, plus 3 is 1 over, done. Make sense? Okay. Take a look at number 4. Can I plug in 3 on top? What do I get? 0. What do I get when I plug it in on bottom? 0 over 0 means your favorite dead mathematician, L'Hopital's rule. Okay, limit as x approaches 3. Derivative on top, what is it? Derivative on bottom, plug in a 3. 2 times 3 is what on top? 6 over 4. Reduce it if you want to, but for your response you don't have to. Okay, let's go down to number 7. Plug in a 0. Okay, now this one I'm going to write out like an FRQ, okay, just so that you remember how to do it. You cannot on the AP test do this. You're never allowed to put 0 over 0. So you would do the limit of the top and the bottom separately. Do y'all remember talking about that? Okay, now again, if it's multiple choice, nobody cares. But if it's free response, you can't put equals 0 over 0. So what you would do at that point is say, okay, well if I plug in 0, cosine of 0 is what? 1 minus 1 is 0. Then for x, plug in a 0, you get 0. When those two limits come out to 0 separately, then you do L'Hopital's rule. What's the derivative of 1 minus cosine x on top? Positive sine x. Good job. And then what's the derivative of x on the bottom? 1. And then from there, whoop, plug in 0. Sine of 0 is 0. 0 divided by 1 is 0.
Why isn't it 1 minus sine?
Because the derivative of 1 is 0 since it's a constant. Good question. Okay, let's jump down to number 10, please. Number 10. Okay, plug in a 2. What do you get on top?
0.
E4 minus E4. What's that? Okay, on bottom, 2 minus 2. 0. L'Hopital's rule. Limit as x approaches 2 of what is the derivative of e to the 2x minus 2? E to the 2x times 2. What about E4? What type of function is that? It's a constant, right? E to the 4 is just a number. What's the derivative of a constant? 0. So it goes away. Okay, then derivative of x minus 2 on the bottom, what is it? 1. Now plug in 2. So that'd be e to the what? So it's 2e to the 4. You remember all the things? Okay, let's do number 16. Number 16 is a little tricky. Are you allowed to take the ln of 0? No, so think about the graph. ln x looks like this. What happens as you approach 0 from the right side? Where's it headed? Negative infinity. Or what could you put? dne. Okay, remember that technically I can plug in 0 to that. I can't fix it with L'Hopital's rule. But if I look at the graph, I'm like, oh yeah, there's an asymptote at 0. So you could put it's going to negative infinity, or you could put that it doesn't exist. Okay, next one, let's do number 5. Okay, x is approaching pi halves. What do I do? Good. I want tan of pi halves, which is sine over cosine at the same angle. Okay, now from there, what's the sine of pi halves? Sine of pi halves is 1, but cosine of pi halves is 0. Okay, can I use L'Hopital's rule if I get 1 over 0? They both have to be 0. That's a no. L'Hopital's rule won't fix it. Then what is my answer? dne, or you could put undefined. I can't divide anything by 0. Now, if the 0 was on top, would it be okay? Sure. But if 0 is on bottom, that's a dne. And it's not fixable by L'Hopital's rule because they're not both 0. Okay? Alright, next little section that we're going to look at is numbers 13, 15, and all the ones where h is going to 0. Okay, you may or may not remember this. Do not write this where I'm writing it. Okay, but f prime of x, don't write it, just look, is the limit as h approaches 0 of f of x plus h minus f of x over h. Okay, we covered this in literally September, so I know it's been a while. Okay, but this h approaching 0 limit is the definition of a derivative. One day we worked a bunch of these out the long way, but then the next day I taught you the power rule. So, if I'm looking at number 11, where's f of x in number 11? It's usually here. So what's f of x in number 11? X to the 5, then just take the derivative. What is it? That's your answer. Okay, you don't work those out the long way. You recognize, oh, h going to 0, that's the definition of a derivative. How do I take the derivative? I just circle the function, regular derivative rules. Okay, look at number 13. H is approaching 0. I know it's the definition of a derivative. What's the function that I'm circling? What's the derivative of tan x? Secant squared x. Okay, number 15. I kind of scribbled on it, but what's your function? Circle it. E to the x, and then what's the derivative of e to the x? E to the x again. Good. Okay, number 17. How do I work it if x is going to infinity? Bobo, Botten. Okay, Bobo, Botten, Betsy. Anytime x is going to infinity, you're looking to see who's bigger. 2 to the x is an exponential. X is a power. Who wins? The top. Exponential wins. Is that a Bobo, Botten, or a Betsy? Botten, so it'd be dne. Let's do another infinity. Number 21 right below it. What's that? That's a Betsy, so it goes to 2/5. Okay, do number 22 right next to it. What's that? Bobo, so it goes to 0. Good? Okay, let's look at 23. Do you remember what happens when you plug a negative infinity into an exponential? So it'd be 1 over 2 to the x minus 16. 1 over 5 to the, to the x minus 4. So whenever you have an exponential and x is going to negative infinity, you have to turn those guys into fractions and then Bobo, Bot, and Bed see them. So 1 over 2 to the x, what does that go to? 1 is on top, exponential's on bottom. Just this little part I circled. That's a Bobo. So what does it go to?
0.
What is 0 minus 16? So it doesn't zero out the whole top. It just zeroes out the 2 to the x term. Okay, now look at the bottom. I have a 1 over 5 to the x. That's a Bobo as well, which means it's a 0. But that's not the only thing on bottom. What's 0 minus 4? And negative 16 divided by negative 4 is 4. Okay, let's do number 25. Okay, remember that when you have sine of 1 over x with a limit, you can jump the limit to the middle. So you're going to do x approaching infinity of 1 over x, then you're going to plug the result into sine. So my limit jumps in with 1 over x. Is that a Bobo, Bot, or Betsy? Just the 1 over x part. That's a Bobo. So then that goes to 0. Then what's the sign of 0 in the middle? 0. Make sense?
What does negative infinity do again?
Negative infinity only matters for exponentials because it turns them into fractions, and then absolute values. So do you see one with x to negative infinity that goes with an absolute value? 24. So if x was going to infinity, would this be a Bobo, Bot, or Betsy? Regular infinity. Pretend the negative's not there.
Oh, and then it'd be,
It would have been Betsy, which means that divides to 3. If it's going to negative infinity, it just goes to negative 3. You just change the sign. And the reason why, let me just explain to you in case you forgot. So my top, when I plug in the negative infinity, it stays a positive 6. But on the bottom, the negative infinity goes into the 2 and turns the 2 on the bottom negative. Yes, so instead of being 6 over 2, it becomes 6 over negative 2 because of the negative there. Okay? All right, turn the page. So, lots of limits, lots of limits. We know how to do that with an equation. Number 30, let's do A and B. Your test is 45 questions, 30 no calculator, 15 with a calculator. Okay? No, look at your lovely little graph. It's 15 with a calculator, 30 no calculator.
So I have to, if I get all 13 I have to just, because the calculator makes no sense to me.
Okay, then it'd be a good time to come for tutoring.
This, I tried.
Okay, look at number 30.
Every day.
What is the limit as x approaches negative 4? Look at your graph. Okay, negative 4 is here. My limit as I approach from the left and the right is 2. Okay, what about f of negative 4? Okay, it would be 1. Very good. So remember, your limit, okay, focus. Okay, your limit, you're looking from the left and the right side, making sure they're going to the same place. But for f of negative 4, that's a y value. And a y value would be the closed dot on your graph.
So if it was just an open dot, then
It'd be undefined, correct. Okay, now skip a row, let's do row E. What is the limit as x approaches negative 2 from the minus side? Which side is that? That's the left side. Then which side do I cover up? The right side. So I'm covering this part of the graph up, and I want to know how high my graph is going to. Well, how high is that? 4. Okay, other side, I want to cover up the left. I want to look at it from the right. So I'm covering up negative 2 over. Where does it look like it's headed to? 2. Okay, if my left limit is 4 and my right limit is 2, what's my overall limit? Good job. What is f of negative 2? Why did I pick 4? Because that's where the closed dot is. Very good. Okay, skip a row, go to row M. X approaching 6. X approaching 6. What's my value? Like 2? Maybe 1.5 is really where it looks like it is. Okay, but what about as X is going to infinity?
Let me just ignore them.
Oh wait, what'd you say? Oh. As X is going to infinity, where's it going to? 0. Okay, remember, X going to infinity, you're looking at the right end of the graph. Okay? Then last one like that, take a look at letter O. Okay, where does my limit go? It follows where the X is. So I'm going to have e to the power of 1 over, boom, little baby limit falls in to the equation. Little baby limit. There it goes. I can't. Like that?
I don't like that.
Okay, well for this one, since I wrote it kind of small. Okay, now, look at your graph. Obviously I can't show mine because I'm super zoomed in. But what is f of x doing as x goes to 4 from the left side of the asymptote? It's decreasing forever and ever and ever till when? Infinity. So if this is a 1 over infinity, technically it's negative, but it doesn't matter. Is it a Bobo, Botner, or a Betsy? What's bigger, 1 or infinity? Infinity wins. So this is really infinity under 1 is a 0. What's e to the 0? 1. Okay, that's a good question. Let's talk about. Okay, it does not matter if infinity is positive or negative. You are still doing your Bobo, Bot, and Betsy rules. What are the only things you have to watch out for? Exponentials or absolute value. Okay, and if it's a 1 over f of x, that's not exponential. Okay? Good job. Okay, let's turn the page. Okay, go to number 32. What was that? Yeah, probably 20 points. And you won't have to earn that with corrections because... Now guys, keep in mind, some of y'all seem very dismayed when you get a grade of like a 60. A 50 is passing on AP. That's why you're getting these ridiculous curves, but yes, you're going to have to work for it, okay, by coming in and correcting. It doesn't take that long unless you get like a 10 on the test, and then you have a lot more to correct. But probably that's a good thing if you got a 10. Probably you didn't know a lot of stuff, right? Okay, so a passing for AP is like a 50. So if you feel sad about it, okay, that's okay, but let's get into like our fix-it mode, you know? Yeah, I mean, well, if you're correcting it, though, then it doesn't say a 50.
Right, but like last time I got a 75 and she's still like...
So, but then it's really a 95 when you get your correction.
You want to tell my mom that?
I'll tell her. I'll email her.
Yeah, like,
Tell me her email. Okay, 32. What do you do to make a function continuous?
Good question.
Okay, yes. Okay, if it is a piecewise, okay, listen. If it is a piecewise, your left and right limits need to come out the same. The top portion of the piecewise represents the left limit. The bottom of the piecewise represents the right side limit. So all that I would do is let x squared plus k be equal to 3k minus x. And then plug in that x is 1. Now that one is a little bit easier than number 33, so we're going to do that one instead. Continuous, what do I set equal? We just did it. Left equal to right, but what about differentiable? What else do you set equal? The derivatives. L prime equal to R prime. Okay, so continuous means the original left and right are equal. Differentiable means the derivatives left and right are equal. So, let's do it, shall we? Ax squared plus 10 equal to x squared minus 6x plus b. We're going to plug in x equals 2. Okay, from there, I'm going to let the derivatives also be equal. Okay, what is the derivative of 2ax squared plus 10?
2x plus 10 0 plus 0.
Okay, good. Other side?
2x minus 6.
What about the b?
It is gone.
It's a constant, so it's gone. Good job. Okay, then from there, what do I know about x? X equals 2. So if I plug in a 2 to that, what is 2a times 2? Okay, 4a. What's 2 times 2 over here? 4 minus 6 is, if 4a equals negative 2, then what does a equal?
Negative a half.
Negative a half or negative 2 over 4. You don't have to reduce, but you can. Other side, now I know what a is. I know what x is. Well, then b is going to be the only item I don't have. So I'll have negative a half. My x is a 2 squared plus 10. Then I'll have a 2 squared minus 6 times 2 plus b. What's 2 squared? Okay, can you tell me your question? So, negative a half I just found. That's why I put it where a was. And then all the x's I'm just subbing a 2 in. So what's 2 squared here? What's negative a half of that? Negative 2 plus 10, okay? Other side, 2 squared is 4. 6 times 2 is minus 12 plus b. Let's combine like terms. Negative 2 plus 10, what do I get? 8 equals. 4 minus 12 gives me a negative 8. Can I cross the 8s out? Oh, they're not even on the same side. You got to add the negative 8 across. Plus 8 plus 8. Good job. So now you know your A and your B. Okay? We didn't do I was just telling you how to do it. You just set the sides equal. Okay? Alright, I'm turning the page. Good? Do you want to take a picture of it? Look, here it is. Hurry up. I guess I'm going to send you the key either way, so. Tonight. It won't have all of the problems worked out, but it'll have the answers to where you'll know if you're doing it right. Okay, we're going to number 38. 38. How do you check where a function is discontinuous? You need to check for any numbers divided by 0. Okay, what that means is that you need to factor the top and the bottom and look for what can cross out. Okay, discontinuities happen when you get divided by zeros. Now, there are two types of discontinuities. There are wholes and there are asymptotes. So, when I factor the top, what can I pull out of both? So, an x minus 1 will be left over. From the bottom, what will multiply to negative 4 and add to 3? Okay, 4 and 1. And then which one needs to be positive, which one needs to be negative? 4 is positive, 1 is negative. Okay, the factor that crosses out creates a what in the graph? Hole. Where will the hole in the graph be? Now, maybe you remember this, maybe you don't. Okay, a hole is the word that your pre-cal teacher taught you. Technically, it's called a removable discontinuity. Good job. Did your pre-cal teacher use that?
She said removable discontinuity.
Oh, good. Who was it? Oh, good. Go Miss McDaniel. Okay, now the leftover bottom creates a what? Vertical asymptote. Very good. Where will my vertical asymptote be? Negative 4. So if it's a plus 4, you just switch it to a negative 4. Now, from there, the name of that discontinuity is an infinite.
Why is it infinite?
Because it goes to infinity since it's an asymptote. So like it would either be going like up to infinity or down to infinity. Okay? And then if you want to make yourself a note, holes are the terms that cancel. And then vertical asymptotes are left over on the bottom.
So if it was left on top, that would be horizontal.
No, actually, so horizontal you do Bobo, Bot, and Bed C. If it's left over on top, fun fact, that means it's an x-intercept. Yeah. You don't really have to know it, it's more just for fun. But if you have an x left over on top, that's where it would have hit the x-axis. It's a 0. Now, in this case, did I have an x left over on top? No. Okay. Alright, let's do number 39. What do I need? Hannah, tell me. Very good. For an equation of a tangent line, I need a point and I need a slope. How do I find the point? Plug 1, which is my x value, into the original. So I'll have f of 1 equals negative 2 times 1 squared plus 2 times 1 plus 3. But what's my first little term? Negative 2, what's that? Plus 2, cross out, then plus 3. So I have my point. How do I find my slope? Take the derivative. Kind of. Okay, negative 2x squared, what's the derivative?
Negative 4x plus 2.
What about the plus 3? Constant goes away. Plug in your 1 to know the slope. Negative 4 times 1 is negative 4. Add 2, what do I get?
Negative 6.
What? You joking? Negative 4 plus 2. So like, you borrow $4, you pay me back 2. Still owe me 2. Okay, then from there, what do I do? Point slope form. Now, look at your answers. Are any of those in point slope?
No, they're in y equal.
But you can easily fix that. You put it in point slope, then solve it to match one of those. So I'll have y minus 3 equals negative 2 for my slope, x minus 1. Make it look like this. Which one can I cross out, though, that the slope's wrong? That's a positive 2, so I can automatically cross that out. Times your negative 2 in. Negative 2 times x is negative 2x. What's negative 2 times negative 1?
Negative 1.
Then add the 3 across.
Negative 2x plus 5.
Yep,
Can I use the restroom?
you may. You're welcome. Good. Okay, next one. Find the points on the graph where the slope is 3. How do I make a slope of 3? Take the derivative, that's what a slope is, and then set it equal to 3. Good job. So what is the derivative of that equation?
Give me your walk right now.
No. Well, okay, so the question was, do you have to label on the semester exam? Okay, I would say 2 things. The free response part, obviously, yes, that's going to be graded as an FRQ. Okay, but the multiple choice, no. But if you don't show work on it, we're going to correct it in the spring in class one day, and if you don't show any work, you're going to have to literally redo every problem. So, huh? What? That would be impressive.
I know, but like, why are they so consistent?
Correct.
Why are they so, like, because, like, if you think about it, SAT, ACT, you have a set limit of time. So why were they so persistent on showing your work?
So
Not everyone has, like, that amount of time.
you only have to show your work on the FRQs. On the multiple choice on the AP test, you don't. The reason I make you do it is so that you are used to it for the FRQs. Okay? So, refocus. Derivative. What's the derivative of f prime? 3x squared. And then what slope do I want? 3. Well, then what does x squared equal? And if x squared is 1, then what is x? Okay, now reread the question. Did we find what they want? They want points. I have x's. How do I find the other half of the point? Original. So my first point is 1 comma something. Then I'm going to plug into here. What's 1 cubed? 1 minus 2. That's my first point. And my second point is a negative 1 for my x value. What's negative 1 cubed? Minus 2 more. Negative 3. Make sense? Alright, turn the page. Couple more.
Wait.
Okay, 41, I'm not going to do it because it's not actually that hard, but how do you make equations parallel? Same slope. So you're going to take the derivatives and you're going to set them equal. Okay, so remember, what does parallel mean? Same slope. How do you find slopes? You find derivatives. Do you want to do that one? Yeah? Okay, take the derivative of the equation. What do you get? 2x minus 2. What's the derivative of the other one? Negative 1. And then can you solve that to find the x? Okay, so add your 2 across. Negative 1 plus 2, what do you get? 2x is 1, then x is 1/2. Now, you have an x value. What did they ask you to find? Equation of a tangent line. So what 2 things do I need? Point and slope. Now question, one of those I already have. What do I already know I want my slope to equal? Remember, what was the slope of the line? Negative 1. Well, then if I want to have the same slope as that, I already know my slope is negative 1. So I'm going to write that over here. My slope is negative 1 because that's what I set the derivative equal to. And then for my point, I know that my x is 1/2. Now, what graph do I want to be tangent to? The curve or the line they gave me? Tangent to f, the curve. So I take this, plug in here. So what is 1/2 squared? 1/4. Minus 2 times 1/2. Well, that would be 1/4 minus 1. Yes, and then I'll change my 1 into a 4/4. And then I'll get negative 3/4. Does that make sense? And that level of arithmetic you should be able to do without a calculator. Well, my kid could do that. So, so it'd be y plus 3/4, negative 1, thank you, x minus 1/2. Literally the other day, we were driving to his Cub Scouts Christmas party, and the GPS, you know, like counts down how far away you are, so it was like 1.8, and he goes, 1 4/5. Then it like goes 1.7, 1 7/10. And at first I didn't know what he was doing. Then it was like 1.6, and he was like 1 3/5. And anyway, then I realized he was literally just doing fractions. And I was like, now make it an improper fraction. And he like kept doing it. It was so dweeby and cute.
That's like level of shortness.
Like, he'll have no friends, but he'll be good at math. Because even like me, I was like, what are you doing? And he was like, how far away we are in fractions. I was like, Okay, one more.
I never got the ice cream sundae now.
Okay, which one do you pick? One more, last page. 42 just means calculator.
46.
Yeah, 46. 47.
Okay. 47. Now listen, we're going to do more tomorrow, so it's okay.
And 47 if we can get 47.
Okay. Alright, we're going to do 46. In case you did not hear, a little star means you get to use a calculator. Okay? So, number 46 is the one that we picked. We want to write the equation of a tangent line to the graph of G. What two things do you need? Okay, for a point, what's my x value?
3.
Okay, my y value, I need G of 3. Now, if you are one of those people that you never read the question, okay, it says that G is given by this equation. So G is not f of x, it's x times f of x. So it'd be 3 times f of 3. Yeah? Because I have an x f of x. Now, what is f of 3? They gave it to you. F of 3 here is 8. So 3 times 8, 24 is my y value. Now, here's the reason that matters. If G is x f of x, what rule do I need to take the derivative? Okay, also see the hint. Use product rule. So, u is x, v is f of x. What is u prime? What is v prime? So my derivative would be one diagonal plus the other. So g prime of x, make sure you're labeling equals. Then I'll do 1 times f of x plus x times f prime of x. And then from there, I'm plugging in my value, which is a what? What's my x though? 3. So I'd have f of 3 plus 3 times f prime of 3. And then that's where you just look back at the crap they already gave you. What is f of 3? 8 plus 3 times what's f prime? So that's negative 15 added to 8. What do we get? That's my slope. And then from there, you'd write your equation of your tangent line. Okay? So y minus 24, negative 7, x minus 3. Negative 5 is, they gave it to you right here. So if they hadn't given you that, you couldn't have done the problem. Okay, you have lots of time to work. If I met y'all at Panera on Monday night to help y'all with this, would any of you even come? Yes. Or would I just be sitting there by myself? Okay, the one right here. Okay. So Monday night I will go there from Panera right there. That one's pretty big. Send her mine. I will, but if you don't come, I'm just sitting there with my sandwich. Wait. And F all of y'all.
What time?
It'll be on Monday, so probably 5:30 to 7:30. The one right there. I did it while I was right there. What's right there? I need break. Oh yeah, I was gonna go watch it. This ain't no dang ombre, Kimberly. Victor. Getty. I didn't do it last time. Everything was 500. Yeah, and that wasn't even. Oh yeah. I got 95. What I do on your I had copied this off of the wall. Oh wait, you're not. So. Boy, I swear! Oh my gosh, I recognize that I have the wrong version. I do it all the time.
We don't even look alike.
Dang.
I don't claim that child.
Did you know that you have the same birthday? And I got to see two of you yesterday.
But Q's birthday was not yesterday.
It was yesterday. You missed it. Bad dreams. Yes, I'll be here till 5:30.
Wait, what time?
Kevin, till 5:30. Monday it'd be 5:30 to 7.
Why did I only get 36?
And I'll have my 4 little kids there with me.
My wife is 68 to 68.
Oh, the floor!
Oh, bro, thank God I had
I really like it. But bro, you should see my music. It's black. It's black. And then we're just
Make sure when you talk to God that you say, that's what you have to say. So I
the first one, I don't really like that. The first piece.
Coach said that. Coach said that. Coach from the
Yes. And that's because you know what. So just come in and visit. You don't have to do the whole thing again.
Are you doing it right again? Because I got one done. I love it.
How many months
It's not due till the last day for Labor Day.
Because your birthday's in March.
I don't have anything. You come a period after I should be back in my room. Jenny, yes, somebody.
February. Oh, you're on February 27th.
Is that correction?
Oh, that's my birthday.
I am so proud of
That's
myself.
so funny. So what I got
It's my birthday minus no plus 9.
they have not been one of the things.
Yes, it is. So remember, look. So remember the number of birthdays. Mine's February 23rd. We're the same birthday, but it's just minus plus 9. Bring them up.
When your birthday's on the February.
No, I think that he just went to Gunner first, and Gunner wrote on his paper. So that he can't, Tim seems like she's just like, okay, or hey, I mean, there's something to think about, but it seems like Gunner's the only one that's telling you, you should go to Tim. If you're, are you wanting to draw? You won't be drawing, but I mean, so anyway, yeah, you can, but I would go to Tim.
I just want to go to another question. In that thing, do you have homework 8 and homework 9?
I don't. I only brought down the semester exam review.
Okay.
But if you come up, they'll make an announcement at some point
When the hallways are opening?
saying, yeah, when testing is over, and at that point, then you can come up there and get whatever
I don't
homework
know
you need.
like what days that I officially came to tutoring, but I know I come during lunch and I came after school, but I don't know what days that I like.
For hours or something?
No, I don't need hours. It just says
Huh?
like
When did you put in the text?
When did I?
Yeah. Because like I didn't think you put in mine.
I might not have known you were. Did you put it back on the tray?
I put it like on your computer.
Okay, then I have it in my little cart to grade right now.
Okay.
So I'll do it, but shoot me a message on Remind if you don't see it by the end of today.
Okay.
Okay. Who did you go to? Tim's?
yeah, she said I had to fill out all of this because I just wanted her to sign it so I can make sure that I can turn it in tomorrow.
Okay.
But I can't sign it tonight.
So I'm gonna put, you wanted to drop at 6 weeks, right?
Yeah.
Okay, so that is what I would say is, she told me to really keep trying until this, at 6 weeks when I wanted to drop, and that's what I'm gonna put on here. Convinced her to stay until semester to try and get used to pacing, still really struggling, has attended. Did you do test corrections this time around?
I think I didn't finish my test corrections, but I did test corrections for test 1, but not for test 2.
Okay. And then I put on there you've come to tutoring and done some test corrections. so that she'll know that you at least, it's not